So, hi everybody, welcome to today's cloud coaching session. Today we'll be covering Oracle Interconnect for Google Cloud, which we have recently announced, and very proud of this partnership with Google. Today I have got two more presenters with me to go through the content for this session. My name is Ejaz Akram. I'm part of the Multicloud specialist team as a EMEA lead here at Oracle.
Hello, I am Ricardo. I am also part of the Multicloud specialist team covering EMEA.
And hello everyone, my name is Emanuele. I'm the EMEA networking practice lead for Google Cloud.
Thank you so much, guys. So let me quickly go through the agenda for today. So in today's session, we'll have a good overview of the service, the Oracle Interconnect for Google Cloud. We'll look into the resiliency design, which is how and what we can achieve. And then we will cover ECMP option as well, how to enable and what we can get. And finally, we will conclude with the demo to actually showcase you how easily and quickly you can build the service and start using it. So in a brief overview of the Oracle Cloud Infrastructure with the Google Cloud Interconnect, I would like to cover a few things here. So what we are doing here basically for customers to build their multi-cloud solutions and be able to connect the two clouds seamlessly. For the optimal performance, we're ensuring the lowest possible latency between the two clouds while keeping this traffic private and secure. A flexible capacity, on-demand virtual connections that can be provisioned within minutes. With the streamlined support with end-to-end SLAs and a very proactive and monitoring and alerting. And finally, the cost optimization with the zero data transfer cost over the cross-cloud environments. So this is something which we have already deployed within multiple regions, 11 globally. The one you see here on this slide, we've changed the color to green just to highlight the EU or European regions. Currently we have Madrid, London, and Frankfurt. And that's where we have been doing our testing, and later on in the demo, you will see some latency results we have so far. So with that, I'm going to hand over to Emanuele to take you through the further slides, and then Ricardo. Thank you.
Thank you very much. So in this slide, you see a logical, I would say, a layer 3 application view of what the Oracle Interconnect for Google Cloud is. And what I'm going to do, I'm really quickly going to explain to you the leftmost part, so the blue part, the Google Cloud part. So there's of course a Google Cloud region, and we got a VPC. So the VPC is global, of course, in Google Cloud. And in this example, though, we're looking at regional components, right? So imagine you have your application servers, could be Compute Engine, could be GKE, they could be in every region that are covered by Google Cloud. And you have a cloud router, which is a regional entity, and the cloud router sits, let's say, in the same region where you create the attachment. So in the demo, you will see that we use the Europe Southwest region, so the Madrid region for both Google Cloud and OCI. And Cloud Router is a BGP speaker. It's not doing data plane, it's only doing control plane. And it talks BGP to the DRG on the Oracle Cloud side. And Cross-Cloud Partner Interconnect is the logical layer 3 link between the Cloud Router and the DRG. And as we said, there's a target for less than 2 milliseconds, less or equal to 2 milliseconds round trip latency between the two direct connect regions. Go, Ricardo, if you want to chime in and explain the Oracle side.
Yes, thank you. So for the Oracle side, basically what we need is first the DRG, which is also a regional construct, so it's resilient in a region. And this is where we will attach the Fast Connect. The Fast Connect is the private connection that we will use to reach, in this case, the Google Cloud region. Apart from that, then we will need, the customer will need to have a VCN. The VCN is the virtual cloud network where they can deploy the resources, any resources they need. Okay, so for For example, here, as you see in the picture, there is an Oracle database running in Exadata infrastructure, but with this solution, you can deploy any service you want that is available in OCI and connected to GCP. Of course, for getting the connection to work, you will need to set up all the necessary routine to get this working. Back to you.
Thanks, Ricardo. And by the way, in the demo, you will see that if there's a specific option when you create the attachment on Google site, the pairing keys, if you select that option, the routing is BGP session is automatically established for you. So it makes things very, very easy. So this is a similar view of the solution, but more on the physical side, so to speak, right? So there are a few points that I want to highlight here. So first of all, Google and OCI have pre-built and maintain dedicated physical connections between the respective edge devices. It's what you see in the picture. You see there are two blue, let's say, if you look at facility 1, there are two blue devices on the left and two Fast Connect Oracle devices on the right. So it's a dedicated physical link, multiple, of course, between our interconnect and the Fast Connect. It's multi-tenant, so many customers can use these links, and the provisioning is super fast. We're really talking about a few minutes, and you will see an example in the demo, because from Google side, it's the same swim lane, the same workflow that you use to create partner interconnects attachment. So you create the pairing keys and then use the pairing keys on the Oracle console. And of course, as Ejaz was also saying, there is support coordinated between us and OCI to make sure the service is up and running and troubleshoot. In this picture, last point, you will see that we like Oracle have at least two different physical devices, the blue ones, in two different edge availability domains for every facility location. So this gives the IHA characteristics, and over these interconnects, we create VLAN attachments, right? And you see multiple VPCs belonging to multiple different customers and a cloud router with two VLAN attachments. Those VLAN attachments are the ones where the BGP sessions between the cloud router and DRG runs. Back to you.
Yes, thank you. Okay, so from a resiliency point of view, in this service, in the Oracle Interconnect for Google Cloud, if we want the service to be resilient from OCI, we will need to configure two virtual circuits. Okay, so as I explained earlier, the DRG is a regional construct, so it's resilient in a complete region. So if we want the connection to Google to be resilient, then we will need to create two virtual circuits and attach them to the DRG. Okay, by doing this, we will get the service redundant, okay, within the specific region. Then there is another option available in OCI, which is ECMP. So basically what this means is that we could be able to use the two virtual links, okay, in an active load balancing mode. Okay, the configuration, the initial configuration is also resilient, but by enabling ECMP, customers can have the option of using active load balancing. In OCI, ECMP is off by default, but the customers can decide to enable this on a per DRG route table basis, as it is shown in the diagram, and we will also cover this during the demo. Okay, so now in GCP, Emanuele will explain to them.
Yes, thank you. So this is the GCP view. So the attachment has been set up, the routing is being correctly configured. So this is the end state. And specifically, we are looking from the VPC point of view, we are looking at the routes, and on the top, at the top, we're looking at the routes in Europe Southwest 1, Madrid, which is the local region, the same region where the attachments are terminated, the attachment with Oracle, and the same region where the cloud router is created. So as you can see, we have two routes for the same prefix that is coming from Oracle, which is on the Oracle side. And why two? Because as I said, two BGP sessions, two attachments, so we receive the route twice. And equal cost multipath is enabled by default, so both these routes can be used, which means that the bandwidth will be shared, both the attachments will be used. So on a per flow base, there will be load balancing across the two attachments. Priority is 0. Priority is, by that value is the BGP met. So by default, let's say the router is being sent in this example to us with a multi-exit discriminator value of 0, and Cloud Router basically takes this value and write it in the priority of the route. And priority is important because it's a parameter that is used in the route selection process. But we said that the VPC is global, so the bottom view is for the same VPC, but for a different region. Milan, in this case, Europe West 8. And you see that we have both routes still. So if you have workloads in Milan, they can reach in GCP in Milan, they can reach the OCI workloads in Madrid. And the priority is not 0, it's 220, because when we program routes, dynamic routes across regions, we add automatically, the system adds automatically what is called an inter-region penalty. So in this case, it's 220, and so 0 plus 220, 220, and that's why in the bottom you see the two priority for the two routes, 220. These ensure that if by chance you have also some local routes coming in Europe West 8 for the same destination prefixes, you will use the local routes and not the cross-regional routes. In this case, there are no local in Europe West 8, so you go to West 8, Madrid, and then OCI. Back to you. No, sorry, it's for me. So that the swim lanes, right? What we call swim lanes. So how you configure on the Google side this product. So again, it's basically the same swim lanes that you are familiar with when you create a partner interconnect attachment partner based, right? So you create a new partner interconnect attachment. You have an option to create a single attachment or already redundant set of attachments, so two. And if you create one, then the system gives you also later on the possibility to add the second redundant attachment. So you can start with one if you want, and then just add the second one. And it's very simple. You just, let's say, generate the pairing keys after you specify the usual details, so the region, the VPC, the cloud router, IPv4 or IPv6. Once you do that, you receive two pairing keys, right? And those two pairing keys are the ones that you are going to use in the Oracle console. If you have not specified automatic activation, then when Oracle side the provisioning has been completed, you need to manually come back here and activate the attachment. If you specify auto activation, then as soon as the Oracle side is completed, the BGP sessions will be automatically deployed, and you will start see the routes. And that's what actually we'll see in the demo. Ricardo, I think you have similar swim lanes for Oracle.
Yes. So so the process in the Oracle side is also quite simple. So here, actually the connection to Google is just as if it was another partner. So in Fast Connect, we have two options: one, Fast Connect Direct, where you will actually need to do the physical cabling, or just a Fast Connect partner. In this case, basically the customer will need to select as partner Google Cloud for establishing the connection. Then after this, just provide some basic information for establishing the connection, like just a simple name. Then a customer will need to select the DRG that they want to attach the connection, then select the bandwidth, the MTU, and finally provide the pairing key that we got from GCP. So this is important that first, prior to doing this, you need to get the pairing key from Google. Okay, so as we explained earlier, for having the connection redundant, we'll need two virtual circuits. So this means that we will need to do this twice. So after creating the first connection, then we will have to start the process back again for the second connection, and the process will be exactly the same. Go to Fast Connect Partner, select as partner Google Cloud, OCI Interconnect, provide all the information required, and then create the connection. Okay. So with this, we'll go into the demo where we'll create a simple connection between GCP and OCI, and we will do a ping for a specific for this specific demo. We did it in the Madrid region. Okay, so as a spoiler, have a check on the latency that we got there. Okay, so thank you all, and let's go to the demo.
Okay, so the first step is to create a pair of attachments, of VLAN attachments. So we'll do a partner interconnect connection, and we don't want in this demo to set up an encrypted interconnect, so we just do unencrypted, and we continue. We already have a service provider because that's OCI in this case. So we want to set up a redundant pair of VLAN attachments. Okay, so that's the first option. So the network to which they will be connected is -VPC, and it's Europe Southwest 1 because we're doing Madrid. And we have a cloud router already defined. And the attachment name, we can give it any name that we want. So we can give the OCI VLAN A. We can go up to the maximum NTU, but yeah, it should be the same as the VPC. So my VPC I think is 500, so we'll keep it this way. And the second VLAN, same cloud router. We're gonna call it OCI VLAN B, single stack, and again 150. Okay, so we're good. So again, to recap, redundant VLAN attachments, both of them are in Europe Southwest 1, and then we specify the cloud router and the MTU. Okay, now what is happening is that the system is creating a couple of pairing keys that must be used in the OCI, in the Oracle Cloud console. Okay, so we enable the pre-provisioning. So as soon as the Oracle side will be up, we will have all our PGP sessions automatically being done for us. It's not necessary, of course, but it's just to make things easier. And okay, so now I have two pairing keys. So this is the first pairing key, and so now I need to pass this to pairing key to my Oracle friend.
Okay, so now we'll continue in the OCI side. So the first thing is to be sure that you are in the region where you want to create the fast connection to GCP. In this case, it's Madrid. So here we'll click on Create Fast Connect. Well, first you need to go to the handler menu under Networking, Fast Connect. Here, Create Fast Connect. And here we'll choose the Fast Connect partner. From the drop-down menu, we'll select Google Cloud OCI Interconnect, and we'll click on Next. We will provide a name, in this case going to be GCP1, and you can select the compartment where you want this Fast Connect connection to be created. In this case, well, the connection will be a private virtual circuit because we'll be connecting to an OCI tenant, and well, the traffic is going to be all the traffic, okay? Then the Fast Connect needs to be attached to a DRG that should already be deployed prior to doing this step. We'll select the one that it's created. Be sure also to select the compartment where this DRG exists. Then we'll select the bandwidth, which is 1 gig, as Emanuele did on his side, and the partner service key. I'm going to put the service key that we got from the GCP console, okay? The MTU is going to be 1500. We could select also 9000, but let's use 1500 as it was on in GCP. Any advanced options, if you want to add any tags, in this case we won't, okay? So with this, we'll create the first connection to GCP. But as we explained earlier, to have this connection redundant, we will need to create an additional connection. So as you can see, the status of this connection is in provisioning. So let me create the new connection. So we'll follow the same steps. Fast Connect Partner. Here we'll select Google Cloud OCI Interconnect. Name, let's use GCP 2. DRG, the same DRG. Provision bandwidth 1 gig. We'll put the segment partner service key, MTU, and we'll click on create, okay? Okay, so this may take a while, so we'll wait a bit for the sessions to be, for the Fast Connect to be provisioned. What we should be expecting is for the both circuits to be provisioned and for the BGP to come up, okay?
Okay, so welcome back. So as you can see from the Google Cloud Console, the two attachments are now operational. They're both green and up, both 1 gigabit per second of bandwidth, and was configured on the Oracle Cloud side. And they are connected to the single logical cloud router. So it's a single logical, but it's a redundant object. So if you look at one of those two VLAN attachments, we see that the cloud router has an IP address, and on the other side there's the DRG IP address. This has been auto-allocated by the system. We didn't have to configure anything. And also the BGP session has been auto-provisioned and it's operational. So if you click, you can see some details of the BGP session, and you can see that we are advertising a couple of subnets from GCP towards OCI. What are we receiving is to see that we change the menu. We go into the VPC routes view, and in Europe West Southwest 1, so Madrid, where the attachments are connected, you can see that we receive 10.100.100/24 twice. One over VLAN A, so the BGP session over VLAN A, and the other over the BGP session over VLAN B. Equal cost multiplet is automatically enabled by default in GCP, so both those routes are programmed and active and available in the data plane. Finally, we have 3 test instances in the Europe Southwest 1 region. So we just SSH into one of those VMs, and what we are going to do briefly is we're going to ping an IP address that is on the other side, which is 10.100.100.215. There is a VM on the Oracle on the OCI side, and this is a successful ping that proves that data plane connectivity is actually working. And with that, back to you.
Now in OCI, as you can see, the 2 Fast Connect connections that we established with GCP are up. So now let's see indeed this in detail. As you can see, this is the virtual circuit information that is shown as provision, and the partner is Google Cloud. The BGP status is up. The information for the BGP peering was sent from the GCP side. So this is the IP that is configured on GCP, and this is the IP address that is configured on OCI. Well, in OCI, we use the same autonomous system number, which is 31898, and this is the autonomous system number from GCP, okay? Now let's go to the DRG. As you can see, this Fast Connect was attached to the DRG, and it was attached to the default route table, okay? Of course, if you want to be more precise in a production complex environment, you can create a specific route table for this and then just change the attachment, okay? But now just going to the route table, let's see the routes that we're getting. So as you can see, we're getting the routes from the 2 virtual circuits from GCP, the 10.0.0 and the 10.50/24, and it is shown as conflict, the route for example, 10.0.0 is conflict, and 10.0.0 is conflict is active in GCP2's virtual circuit. The reasoning behind this is that in OCI, ECMP is disabled by default. If we want to enable this, then we will have to, on the route table, the DRG route table, we'll have to click on edit. Here, just click on enable ECMP, okay? So by doing this, now when we click on get all route rules, what we should be expecting is for both routes to be shown as active, okay? So let's refresh. Oops, sorry. And as you can see now, the routes are shown as active. This means that ECMP is enabled and the configuration is fully redundant. One last thing, as you can see here, also in the DRG, the Oracle redundancy status is shown as redundant because we have two virtual circuits to GCP. Okay, and this concludes our demo. Thank you.